All right. Hello, everyone. Welcome to today's Let's Discuss a Paper Right After Reading It. Today, we have read the newly published, already almost viral on Twitter paper by Anil Seth and Tim Bain titled Theories of Consciousness. This is a review paper that gave a very comprehensive summary and review of 4 categories of consciousness theories and identified some of the constraints and challenges for theory validation, validating different, theories of consciousness. And let's start by introducing ourselves. My name's Liang Qianchen, and I am from Monash University. I'm a PhD student at the Tsuchiya lab. And Aniko?
Yes, my name is Aniko Kuster, and I'm also a PhD student at Tsuchiya lab at Monash.
And Yoha?
Hi, I am Yota Kawashima. I'm a research assistant at ATR in Japan and Monash University, Australia.
Okay. So in today's episode, we'll start from summarizing the paper, which is done by me, and we'll discuss a little bit on, our thoughts after reading this paper. All right, let's start the summary. So in this paper, the authors first identified among all these consciousness theories, the kind of specific aspects that these different theories attempt to explain. And then they proceed to summarize 4 categories of consciousness theories, their core claims, their scopes, and the comparison with the other categories. And then they proceed to identify the current debates and constraints in these theories, and also gave some future suggestions. So for the kind of preliminaries, which is like the kind of different explanatory targets of each theories of consciousness, the authors identified 3 main aspects. The first is global versus local states of consciousness. Global means like the overall state of the system related to arousal and behavioral responsiveness, such as wakefulness, sleep, anesthesia, stuff like that. And then on the contrary, we have local states of consciousness, which is like the specific contents of experience, regardless of the level of consciousness. For example, what it is like to see red, and what it is like to feel pain. And the second kind of explanatory target of theories of consciousness is phenomenal versus functional properties of consciousness. Phenomenal property is pretty much just what it is like kind of property to an experience, whereas functional property would relates to how the contents of a certain conscious experience will relate to other cognitive functions. For example, how when you see a thing in your environment, how does this experience allow you to plan your behavior afterwards? And finally, there's a specific kind of target concerning the aspects of local states. The first is why certain local states, aka conscious contents, would become conscious in the first place. And then the second is why does this specific content feel this way? Why redness is like this, but not like seeing blue. And typically, no theories are able to cover all aspects of these conscious experience. They kind of cover 1 or 2 or one specific aspect. And after identifying these preliminaries, now the author summarized, kind of group all this vast number of theories of consciousness into 4 categories. They are high order theories, global workspace theories, integrated information theories, and re-entry and predictive processing theories. So for the first type, high order theories, the core claim is an experience can become conscious, or mental states become conscious when it is captured by some meta representational state. So what is a meta representation? It is a kind of higher order mechanism that monitors the kind of lower level representations in the brain. In a more everyday life kind of description about it, when a person is able to say, I can see something, I can feel the pain, this I can part is the meta representation, whereas the something they see and the pain is the lower level representation. So the scope of explanation for high order theory is mostly on local states, different contents. For example, why something becomes conscious and some others are not, because some representations are captured by the meta state and some others are not. And to some degree, they can explain the experiential character of the experience. For example, the peripheral vision feels rich, but when you actually test it with behavioral tasks, the performance actually suggests otherwise. And they explain it in the way that the meta representation of peripheral vision is kind of inflated and misrepresented. Yeah, and then the shortcoming of this high order theory is they don't attempt to explain the phenomenal character of experience that much. So they don't explain why red feels certain way or pain feels certain way. They just tell you when the system captures this representation or this input, it becomes conscious. And then the next theory, do I need to puzzle it up? I guess so. The next theory is global workspace theory. Basically, the core claim of this theory is when the sensory information is strong enough that it ignites the system, some recurrent network will kind of capture it and then amplifies it to the whole big neuronal workspace. And this big neuronal workspace is mainly consists of high order cortical regions, primarily the prefrontal cortex. So it's kind of different from high order theory in the sense that it does not only require this feed-forward projection from a low level to a high level representation, but it also requires a high level itself to kind of amplify it. Well, there are mainly 3 scopes of global workspace theory. The first is to explain why certain contents become conscious, because it's broadcasted in the neural workspace. And then the second is their kind of heavy emphasis on the functional aspect of consciousness, mainly how sensory information become globally available, and then it can be deployed for report or plan for behaviors. And finally, it also to some degree explains, attempts to explain global states of consciousness, in a sense that if the connectivity of this neuronal workspace decay, the level of consciousness also reduce. And the third theory is integrated information theory, where, let's see, much different from global workspace and higher order theories. It starts from the phenomenal features of an experience, how it feels to have a certain experience. And from there, this theory identifies key features, key phenomenal features of an experience. And then they proceed to propose that any physical systems that kind of satisfy these phenomenal features can be conscious. And how do we look for this kind of physical system? We do this by, first you test the kind of cause-effect power of the overall system, and then to look for the kind of key units that generates the conscious experience, you cut the big systems in various different ways and test the cause-effect power, which is also termed integrated information, in these different smaller cut units. And the minimally sufficient units that generates the most integrated information is the units that generates conscious experience. That's my summary anyway. I'm not sure if it's accurate. And a very key feature of IIT, integrated information theory, compared to the previously mentioned ones, is that instead of looking at frontal regions, they highlight the importance of posterior areas of the brain in generating conscious experience. And when it comes to their scope, firstly, they definitely attempt to explain the global states of consciousness, because they describe the overall level of consciousness by measuring the overall cause-effect power, phi, or integrated information in the system. And they can also explain local states by looking at the kind of cause-effect connections within the system, and use that to describe how do I say this? The kind of, how do I say this? We look at the cause-effect structures of the system, and this particular structure is kind of, according to them, corresponds to the phenomenal characters of a particular experience. So the structure, the connective structure of someone seeing red would be different from someone seeing blue. And you can compare these different structures to investigate, the correspondence between conscious contents and the neural basis. But overall, IIT says very little about, the functional aspects, how these contents, when they enter consciousness, they will be, manipulated in memory and learning. So far, they say very little about this. All right, the final theory is re-entry and predictive processing theories. So they are kind of like two similar subcategories of theories putting together. The re-entry theory is also called recurrent processing. They basically say sensory information that elicits kind of top-down signaling can be conscious. And for predictive coding, it also highlights the importance of top-down signaling, but this top-down signaling is specific to the brain making specific predictions about incoming input. Yes, so facing incoming input, the brain makes top-down prediction about what the next input is. And then the prediction will be evaluated with the next incoming input, and then see how much prediction errors it generates, and decides whether it will update its prediction or keep its current prediction. So that's the core claims of this category. And the main scope of this category is local states of conscious experience, in the sense that, what becomes conscious is whatever that generates top-down signaling, or whatever the predictive processing decides is the most appropriate. It also mentions that it can, to some degree, describe the experiential character of experience. But I personally didn't understand much, so I'll skip here. And then another scope of this cluster of theory is that it definitely talks about the functional aspect of consciousness by discussing the relationship between consciousness and attention. For example, in reentry theories, top-down signaling or amplification is basically attentional amplification of perceptual contents. Whatever that you attend to is whatever you kind of become conscious of to some degree. But these theories don't explain much of the global state, whether you are awake or asleep. They don't talk too much about that. All right, now that I have summarized the 4 categories of theories of consciousness, the author has summarized the 4 categories of theories of consciousness. They proceed to evaluate them. So they identify 3 major constraints / debates in these theories. The first one is the emphasis or lack of emphasis on the unity of consciousness. So the unity of consciousness is, we talk about a lot of different aspects of conscious experience, the contents, the level, what is conscious, what is not. But all these aspects is unified together as a single experience for an agent at any given time. So you don't see, let's say you see a red dot, you don't see its shape and the color separately, and then also feel that you are sleepy separately. No, they're all integrated together. So apparently, IIT gives a very heavy emphasis on this. It's basically part of its axiom in the first place. And global workspace also kind of would agree with this because they have this broadcasting kind of aspect of its theory. Whatever that's broadcasting to this neuronal workspace is part of your consciousness, and you broadcast a lot of things into that workspace. So it's an integrated experience. And on the other hand, other theories such as predictive coding and high order theory, they don't talk much about how these different aspects of consciousness are integrated into one single experience. The second kind of debate or constraint is in how to explain the currently available neural data. For example, all theories would agree would agree that cerebellum is definitely not part of the NCC, neural correlates of consciousness. But why is that? Different theories give kind of different accounts on why cerebellum shouldn't be considered as a system that generates consciousness. But what's important here is not that all of them gives an account, but you need to compare these different accounts and see who gives a most plausible explanation. And that's what should be done next. And the third kind of constraint is the question that can these different theories of consciousness make very accurate, verifiable, and novel predictions. One problem with this is that these kind of novel predictions can be relatively difficult to test. For example, IIT would actually predict that if IIT describes any system that fits with the axioms it proposed would be conscious. But how do you confirm a non-biological system is conscious, right? So this is part of the problem. But it's also possible to improve the verifiability of these novel predictions based on methodological advances. For example, kind of recurrent processing theory and global workspace. These theories, they highlight how the initial input gets later amplified in the brain. So in a sense, these later onset or later activities are crucial for consciousness. The kind of corresponding methodological advances would be to look at the temporal dynamics of neural activity related to conscious experience. For example, looking at EEG or ERP kind of signals. You can see whether the earlier onset neural activity or the later onset neural activity are related to a conscious perception. Sorry. All right. After discussing the current kind of debate and current constraints, now we come to the final section where the author proposed 3 issues to be addressed in the future for validating these different theories. So the first major issue is that all of these theories needs to be very precise in their terms. For example, you need to make clear what exactly are the aspects of consciousness you are trying to address, and what mechanism you're actually describing here. For example, meta representation. What exactly is meta representation? How it is represented in the brain, and what it is exact function. And the author proposed that one way to resolve these kind of lack of precision kind of problem is to use computational models, in which when you attempt to make these different theories into computational models, you have to describe them by very concise kind of processing stages, and you need to compare their input and output so that relatively similar theories can be compared in a clearer way, and then you can make a very clear comparison between the outputs. And the second kind of challenge or issue to address is all these theories needs to be more comprehensive. Of course, they have their own reasons to stay in a relatively safe zone in saying that I'm only addressing this part of the theory of consciousness, and I'm only focusing on human brain. I don't care about animals because we don't know it anyway, we can't test. But it's crucial to at least make an attempt to state your prediction about what would happen to other aspects of consciousness with your own theory. And the final kind of issue is measurement problem, i.e. how to develop trustworthy measurements of consciousness. So this can be broken down to 2 types of measurements. The first is how to reliably detect the contents of consciousness. For example, how do we detect the redness, or how do we confirm that certain participants see the stimulus that's presented on the screen instead of not presenting it, but just giving reliable guesses. And then the second key things for measurement is to decide or to develop a criteria to decide who is conscious and who is not. Well, we can reliably assume that humans are conscious. How can you confirm that other animals are conscious? And also specific to IIT, how do you confirm that a computer can be conscious? All right, that's it.
Well done. Oh, that was super impressive and very detailed. Basically, anyone who has listened to you now, they don't have to read the paper. Yeah. I mean,
I don't know how to shorten this. I think I tried. Yeah, but I think it's important to mention. And I think what's most impressive is how they group together these 4 categories, and then they can summarize and compare. This is very impressive because me, myself, higher order theories and kind of recurrent processing and global workspace, for me, I was never able to see the differences between them very clearly. It was like, it's all top-down stuff. But now I see a clear distinction. Yeah.
Yeah, and I think so. Yeah, we mentioned this before starting recording, but I think this is a very good paper for anyone who is interested in consciousness research and kind of interested in getting to know the current state of consciousness research, because it kind of very well summarizes everything that is like important and kind of worth considering.
Yeah. So anything kind of noteworthy?
Okay, so I have one comment about the measurement problem, right? And says that, we should not trust only, introspective, reportable or report if we want to, measure subjective experiences, something. But we should not rely on any theory-based, measures. I understand what they say, but I'm skeptical whether it's possible or not.
Well, no report paradigm exists, I guess.
Yes. Yeah, I see. But okay, I see. Yeah, no report paradigm.
Yeah, but I also get that maybe they don't just mean let's use no report paradigm. It probably means something else, but it's really hard to come up with an alternative, because to measure consciousness, unless you use a no report paradigm, you have to ask for report. If you don't ask for report, then it's probably just, you are probably just kind of implying that we'll use neural measurement, which again will rely on theories, because do you want to look at the parietal lobe or the frontal lobe? This is very theory based.
And I think the authors mentioned the applicability of the measurement to animal consciousness, because they might be conscious of something, but they just can't report it. And if we want to, let's say, use the some no-report paradigm objective measurement to measure conscious contents of animal, let's say, measuring the eye direction while doing the binocular rivalry, fossil paper thing. But it, by measuring the eye direction, we can't say, okay, this animal is conscious of that content, yeah. Right? So,
well, so for example, there are some studies on dogs in MR scanners, and they identified similar areas to FFA that react to human faces, and then I think there are some studies about emotional faces. So with that, you can kind of you could potentially set up a paradigm with faces, or whether with a bistable or so some kind of paradigm which you can look at faces, the responses by faces versus non-faces.
Okay, I see. So in that sense, we should combine, evidence from various perspectives, not only behavior, but also some brain activity and, you know, the location of the activity and things like that. And then by that, we can infer maybe this animal has consciousness, something like, yeah, if so, then I'll agree. But still, you know, it's very difficult to detect whether the animal is truly conscious of that or not. Yeah, we can make inference. Yes, I agree with that.
Yeah, but I mean, in that way, it's also, I guess, the first section of the paper, Deliver describes this kind of, is someone conscious? It's like, this is a difficult question. Like, what do you mean? Is that something conscious of a very specific local, like this local state, like a very specific qualia? Or is it more like, do they have an awareness and like a change in their kind of responsiveness to the environment? So yeah, I think it's like the two are, I think, very different questions, because most animals, I assumed, have changes or show changes in behavioral responsiveness, or for example, like sleep-like behaviors. But then on the other hand, whether certain local states, certain qualia are like possible in certain animals, that's a completely more different and much more difficult question, I guess.
Yeah. And also, while, you know, explaining my idea, I noticed that, you know, we can say the same thing to even, you know, adult human, because I don't know whether you are, you know, conscious or, right? So yeah, my question was more like a philosophical, not practical at all. Yeah, I noticed that.
Yeah, I guess this is always a true struggle to, it's like the essential struggle to consciousness kind of research. Like you measure them, but it may not be reliable. You don't measure them, they could be conscious.
Yeah. So for me, one question I had was again concerning these global and local states, how the authors describe. So I really like this kind of the phrase or the wording, because I kind of see that like the levels of consciousness, how people usually use, or what people usually refer to levels of consciousness, is really kind of implying certain like a one-dimensional approach, and then this kind of global states opens up the opportunity for more like potentially not a single dimension but multidimensional relationships between these states. But what I kind of wondered is how about certain states that are influencing your overall conscious experience and your overall brain state, but they are not considered necessarily in the category of levels of consciousness. So for example, how about sleepiness? How about, for example, sleep deprivation? How about certain moods? How about pain? I think when like there are some states, or how about mindfulness or flow? Like there are these states that strongly determine how you experience the world, what kind of qualia can you or will you experience, but not excluding certain other types of qualia. So I can experience, for example, mindfulness or meditate and then experience paying attention to my feet or my breathing or a candle in front of me, or I can be very sleepy, I can be sleep deprived, and I can experience the world. I can experience many different facets of the world, but it's kind of altered because I'm experiencing it in a sleepy way. I don't know if this makes sense. But then I was kind of wondering if like, would those be considered local states or not?
Good question. I think sleepiness, they would definitely categorize that as a global state. But it's sleepiness, it's actually local sleep.
Yeah, no, but I mean, yeah, so like, of course, it's like, it's also like it has its own qualia, like being sleepy, like you can definitely see like, what is it like to be sleepy? But when you are sleepy, you can still experience a lot of other things. But it kind of changes it, how you experience it, maybe. I don't know. I don't know if perhaps there's a, I'm just misunderstanding.
I think this comes back to the kind of unity of consciousness, right? It's like all these different aspects are actually unified together. I think when they talk about the global states of consciousness, they didn't say these global states themselves don't have a qualia. It's probably, yeah, I give up.
Yeah, I don't know. I think it would be definitely, like, I can see that both of these could be considered more a global or more local state. And then, yeah, I mean, I think it would be interesting to ask. Maybe we should ask Tim, because
Yeah.
Monash.
At least they seems to include psychedelic state as a global state.
Yeah.
So it's a bit difficult. What does the global state mean? Yeah, to understand, the meaning of global state.
They will say the global psychedelic state is like your entire brain is connected to each other, but the specific things you experience is the local states you have during that global state of being on psychedelics.
Yeah, but then you kind of, where do you draw the line? Like this, like what? I don't know, certain emotions or moods, for example, would also count as a global state.
Yeah,
I guess.
Yeah, this is something that I think it's the hardest to kind of tell between global and local for me. Because I think when you experience certain emotions, it definitely also puts a global effect on everything, almost everything, or a lot of things that you experience at the same time.
Yeah,
that's a good claim. When you forgo the single dimensional definition of consciousness, you have new problems.
Yeah, exactly. But still, I think it's a useful way to actually like look at different theories and just like, I think it's a very nice way to quickly summarize, okay, what does this theory wants to do by looking at these, the global and local state and the phenomenal and functional, and then the state versus, or why an agent is in a certain state versus why states are different.
I remember that we in T-Lab had a conversation about, whether the level of consciousness is just a dimension or it's one, dimension of content, something like that. So separating, level versus content is not appropriate. That kind of discussion I remember we had before. Probably, that's something to do with this, terminology, global versus local states. So meaning that, they consider like some consciousness as states, and then it includes something, and they call it as a global, and then the other is local, but they are just all the same states. So meaning that we can't distinguish level versus, contents of consciousness. That maybe that's something what the author tried to say, but I don't know. Just anyway.
Yeah, when you think about it, your visual experience isn't that local anyways.
Yeah.
Yeah.
And
I mean, yeah, I think it's definitely, but I think it's very useful to talk about these questions and what the authors say. I think that was very important to have, like, you know, more theories and more research should be more precise in actually disclosing or being very explicit in what are they like focusing on, what are they doing research on, and how is that related to these like more familiar concepts, or how is a theory or how is an experiment kind of situated in the current consciousness research stage. I think that's something I usually miss from papers, and I always kind of look forward to when a paper kind of in the end just like summarizes, okay, so this was our paper and this is how we can relate it to other findings. Yeah, I do like that idea.
All right. Is there anything else that's noteworthy?
For me, only one question. Do you guys have any ideas about computational, like this computational neurophenomenology idea? Like, do you know of any papers or any kind of work? I don't know. I feel like there's, I know that many people are working on these computational models, but I also think it's like, it's pretty difficult for now. I think we are pretty far away from like actually creating computational models of, for example, the higher order thought theory or higher order or recurrent processing theories, or but maybe I'm just not familiar with these papers.
Predictive codings use a lot of computational models. Yeah, and they
I know one paper talking about the computational model of high order theory. And I don't remember the detail, but published, I think, last year by Aurelio Poltese and Mitsuo Kawato, both from ATL.
Oh, nice.
Yeah, and they have a collaboration with Hakwan Lao. So they have some input from the opponent of high order theory, but still implement the algorithm of high order theory or something. And then there they distinguish metacognition and conscious perception. And I forgot, or to be honest, I hear the presentation by one of the author, and they explain the difference between metacognition and conscious experience in their framework, but it was a little bit difficult for me to understand. But they say that they are different in their model, so maybe it's worth reading it if you're interested in.
Yeah, nice. I would be definitely interested in
metacognition is
seeing
different
this.
from consciousness. I mean, they are two different things, but
Yeah,
metacognition allows consciousness, I guess, in there, right? It's like prediction isn't consciousness. I'm not sure what counts as computational models for a certain theory, but does Angus's like conceptual structures of flies, anesthesias, and wakefulness state kind of computational models?
I mean, I guess if you, based on that, you would simulate something with the same parameters. Like, I think that would be the computational model. So if you would try to create, like, I don't know, some kind of model that recreates what he has identified in the fly vein.
So you develop a model and attempts to apply that on fly data.
No. So no. To instead of the fly data.
You simulate prediction and then you compare it with the fly data and see how it fits.
So that was my understanding of this computational neurophenomenology, is that you are trying to create a model of certain aspects of consciousness, and then, for example, if you apply the same measure to fly data or human data or this simulated data, you would see that, okay, we are getting similar relationships if we tweak this variable. And then from that, you would be able to kind of infer something about fly consciousness or human consciousness. But maybe that was just my my understanding of this idea of using computational, like this computational discussion.
I see. Well, that's definitely not my strong suit.
No, neither mine either. But well, interesting options. I will try to check out the paper Jota suggested. But otherwise, I'm out of questions for now.
All right. And Jota?
No, I don't have any questions.
All right, then I'm also out of questions. So that concludes today's podcast / YouTube video of Let's Discuss a Paper after reading it. Okay.
See you.